Hello, you're welcome to my channel. My name is Harrison. If this is the first time you are watching my video, please subscribe and share to others. Today, I'm going to treat latitudes and longitudes. But before we start solving questions, I have to do a little introduction so that we will take off from there. So we are going to start from latitudes. We know that lines of latitudes are imaginary lines that form small circles on the Earth's surface. The only latitude that form a great circle is latitude 0 degree. So we'll see that. Let me draw and show you what I mean by that. So as we can see, this one is latitude north of the equator. Why this one is latitude south of the equator. And then the equator is this. That is latitude 0 degree. And then under latitude, I told you that lines of latitude or parallels of latitude form small circles, except latitude 0 degree. What I mean by this is this form this line. You discover that the center is here. This one is the equator. It's the only one that has the same center with the center of the Earth. This is the Earth's surface. And then for this one again, this is another center. So you can see that the center of this one and this one, they are different. So that's why I said lines of latitudes or parallels of latitudes form small circles. Okay, so then when we talk of latitude, you discover that this is latitude 0 degree. Now, as you are coming up, it will now continue to increase until you get to 90 degrees north. If you are coming down, it will be decreasing. On getting to this is 0. Then it continues to increase to the southern part until you get to 90 degrees south. So latitude starts from 0 degree to 90 degrees north or south. North or south. That is why under latitude, you'll always be hearing north or south. Then again, when we start solving questions, we'll be talking of latitudes falling on the same part of the either on the northern part or southern part. If the latitude fall, maybe you have 2 points and want to find the angular difference, there's a formula we use to get the angular difference. If you have the positions at the northern part, that's north-north, the formula is that you will subtract the bigger degree from subtract the smaller from the bigger. So I say when we have north-north, that is minus, north-south, that is plus, and south-south, that is also minus. We are going to be seeing this when I start solving examples under that. Then another one is that when we start solving examples, we also mention other things. So let me also show you how we can get our radius. Assuming that this is the radius of the Earth. Okay, let me clean this and draw again. Okay, using this diagram, let me use it to demonstrate. Using this diagram, we have, assuming this is my 0 degree, then this is the center, this is the center, and then from here to here is small r. This is our big center. So I can have something like this, and this is also another radius. Why this is capital R, this is small r. Now, let us use 0 to represent the big center and C to represent the small center. So, again, let us call this alpha, for instance. And then, if this is alpha, this will always also be alpha. Why is it like that? If you have two parallel lines, then you have a transversal. The angle here is alternate to this, so they must be equal. So if you can see that this line here, this radius is parallel to this one. So any angle here must be equal to this. Now, bringing it out, we have, let's draw, we have something like this. This angle 90, this is our C. Let us call this P, for instance. Then this is our P, and then we have our alpha here. This is our capital R. So, and then this is small r. Now, we want to find this small r. We can use sine, cosine, or tan. So, how do we go about that? By using either opposite of adjacent, opposite of hypotenuse, and the rest of them. So, this one, remember, this is our 0. CO is opposite to this angle. CP is adjacent, while OP is the hypotenuse. So we're now going to use R over big R equal to cos alpha. That is adjacent over hypotenuse, which will give us cos. So it means that small r is capital R cos alpha, where alpha is equal to the latitude. That's the latitude of the point. As I said earlier, when we start solving examples, all these things will be clearer. So that is about that. So we have succeeded in getting the value of a small r, which we'll be using when we start solving examples. So that is about the summary of what I have concerning latitude. So the next thing, we are now going over to longitude, and I will also explain things concerning longitude. So when we talk of longitude, these are lines of longitude or parallels of longitude. All the parallels of longitude, all the parallels of longitude form great circles because each of them form a big circle and they have the same center. So lines of longitude or parallels of longitude, they form great circles. And then we measure, assuming that this is our prime meridian, that is, if you measure, we measure longitudes east or west of prime meridian. That means prime meridian is a kind of starting point for longitude. Just like when we talk of latitude 0 degree, when we are talking of latitude. So prime meridian, we measure longitudes east or west of prime meridian. And also for longitude, we talk of 0 to 180 degrees east or west. So in longitude, we'll be talking of east or west. And then in latitude, we discover that when you talk of north or south, you are referring to latitude. So under longitude, we are talking of from 0 to 180 east or west. That means if you are going from prime meridian to your right, you are going due east. From prime meridian to your left, you are going due west. So again, using the formula I used in when I was talking of latitude, if you have the positions along longitude, maybe you have two positions east-east, you will use minus to find the angular difference. Then east-west, use plus to find the angular difference. And then west-west, you also have a negative. We'll be seeing more of this when we start solving examples. So as we move on, you know where and how we'll be using this. Remember that this is our north and south pole, and this is the center of the earth. So let us move on by maybe, as I've explained, the latitudes and longitudes. The next thing is for us to see some examples. So we go ahead by. So we have some questions on the board to find the angular difference between the points on the surface of the earth. So let's start by looking at them. This is a point, this is another point, and so on. So let's start. Now to locate the first one, that is to locate this one, we have to draw north and south, equator, and then this is our latitude 0. So this one says 30 degrees north, 50 degrees west. 30 degrees north, then 50 degrees west. So let's take this to be our A. We have indicated. Then B now, 30 degrees north, that's the same place, but 20 degrees east. So let's take this to represent our B. And then the center, we have this. So we're now looking for the angle between the two. So we can draw it outside. And let's call this theta 1. That's the angle between the two. Let's take this to be our A, B. We are looking for theta 1. And then from the formula, we said if we have east and west, it should be addition. East and west should be addition. So, in other words, for us to find the angular difference, that means theta 1 should be equal to 50 degrees plus 20 degrees. 50 plus 20, and that is 70 degrees. So that's the angular difference. So we have succeeded in getting the first one. Then the second one, we have to also find that, let's see how we can do. Let us draw it here. This is 1, this is 2. Then we draw and indicate. Okay, this one says 20 degrees south, 10 degrees east. So we have, let's take this to represent our 20 degrees. And then 10 degrees east. So the point we are looking for is this. Then 20 degrees south again, 45 degrees east. Take this to be our point. So this one should be C. We have our C here, and then D. So our center should be here. So you have this and this. Let us use C to represent it. And then bringing it out, you have something that looks like this. So we now have D and then C. So what we are looking for is this angle. And let us call it theta 2. We're looking for theta 2. So what do we do? How do we handle it? How do we handle it? We said that if we have east should be minus. So to get the angular difference, therefore theta 2 should be equal to, you subtract the smaller from the bigger. So that should be 45 minus 10. 45 degrees minus 10 degrees. That will give us 35 degrees. That will give us 35 degrees. So we are now going over, we have solved number 1 and number 2. We are now going over to number 3 and number 4. Okay. So again, number 3 now. Number 3 now, we have to draw it in. And then you have your north and south pole, the equator. Okay. So we're now trying number 3. He said 55 degrees north, 40 degrees east. Okay, 55 degrees north. Okay, let us take this to represent that 55 degrees north and then 40 degrees east. 40 degrees east. So this is our point, and that will be E. Okay, followed by 40 degrees north. Okay, that should be down. And then 40 degrees east. So discover that our second point should be here. And then our center is now the big center. So if you check this, we discover that the other first two, the distance was along latitude, while this one now is along longitude. So here we'll be talking of capital R, but in the other one that we saw small circles, we'll be using small r. We'll see that when we start solving more examples. Now, we are now talking of how to get, let's call this theta 3. So if I should bring this thing out, I call this theta 3. Remember, this should be my capital R, and I want to do that because this is the big center. So theta 3 is equal to, again, let's check. Also take note, any value that is coming twice, that is where the distance should be. For instance, here we had 30, 30. That means distance along latitude. Here we have 40, 40 east, 40 east. That means the distance is along longitude. Okay, so moving on, we have 55 north, 40 north. Not north. Remember, not north is subtraction. That is 55 degrees minus 40. And that should be what? 15 degrees. That is 55 degrees north, 40 degrees north. To find the angle between them, you subtract. So that is the angular difference for that. We now come back to check the last one, that's number 4. Following the same method, you have to draw again and then indicate. So we have this. We have north and south. Then the next thing is to now locate the points. Now locate the point. This one is EF. Our F is supposed to be here. Okay. So this one is 50 degrees north, 27 degrees west. 27 degrees west. So the distance is along 27 degrees. So this is 50 degrees north, 25 degrees south. 50 degrees north, then 25 degrees south, 27 degrees west will indicate. So this is our G. This is our G. Then we have indicated G. What of H? 25 degrees south, and then 27 degrees west. So that is here, and that is our H. So the center is here. So if you draw it out, you have something like this. And then let's call this theta 4. Then this is our G, and this is our H. So to find theta 4, again, we go back to our formula. It says north and south is addition. So that will be 50 degrees plus 25 degrees. Because we have north and south. And that is 75 degrees. So theta 4 is equal to 75 degrees. So that is that. So we have succeeded in getting the angular difference for all the questions we have. The next thing we are going to do is to now see how we can calculate the distance of different points. Distance along small circle, distance along great circle. So let's go ahead and see some questions, and then we solve the questions and see how it can be. So we now continue with distances along small circles. We have 2 questions on the board. And then we have this. So we have to find solution to them by drawing the diagram. Question number 1. So we have to find the distance. We have been given the capital R and the small r. So we have this. We have north and south poles. So we now indicate first one, 40 degrees north, 20 degrees west. (20 degrees west). So this should be our A. And then moving on, try to locate the other one. 40 degrees north also, but 10 degrees east. So our center should be here. Then use C to represent the center. So bringing it out to be like this. Then we have A, B. Let's call this theta 1. That is the angular difference. And then since we know that it is east and west, and the distance is along the parallel of latitude, east and west we have to add. So theta 1 is equal to 20 plus 10. 20 degrees plus 10 degrees, and that is 30 degrees. So at AB now is equal to theta 1 over 360 times 2 pi small r. Because we are talking of a small circle. And that will give us 30 over 360 times 2 times 3.142. That is already given to us, times 6,400 plus 40. Remember that you know that R is equal to factor R cos alpha. So our alpha here is 40 degrees. So substituting, we now have, can reduce this. One, this is 12. So we can have it as 1/12 times 3.142 multiplied by 6400 multiplied by cos 40. And then cos 40 is 0.7660. So everything over 12. So when you multiply, you have 30806, then 0.6816. We are dividing by 12. And that will give us 2567.22. So, but we are looking for our answer must be in three decimal places. Oh, yeah. So continuing, we have arc AB is equal to 2570 kilometers. That is about that. So moving on, we are now going to question number 2. We are finished with number 1. Question number 2. So we have to clean this and then, so we have gotten our answer. So question number 2, we have to find the distance between these 2 points. So we try and draw again. North, south, equator, then indicate 18 degrees south, 23 degrees east. 18 degrees south, and then 23 degrees east. That should be here. We take it to be C, and also 18 degrees south again, 67 degrees east. So now remember, this is our center. Take this. This is our C. So now I'm bringing it out. We have something like this. And this is a CD. This is our D. This is our C. Or let's make it. I mean, we have something like this. D, C. Then let's call this theta 2. Theta 2. So theta 2 will be equal to. Remember that when we have the same position, that's east, we have to subtract. That should be 67 degrees minus 23 degrees. That will give us 44 degrees. That's 6, 7, 2, 3, 4, 4. So, and that is that. So, following the same method, we know that arc CD equal to beta 2 all over 360 times 2 pi small r, which will give us 44 over 360 times 2 times 3.142 times 6,400 cos 18. Because our alpha is 18. That's using our formula. Remember, R equals to capital R cos alpha. Okay. So, moving on, we have after multiplying everything, let us write it out first. That will be 44, 360 times 2 times 3.142 multiplied by 6400 times then cos 18, 0.959511. Everything over 360. So we multiply it out, and then that will give us so we have seen the steps we have taken so far. So from here we come up a bit. And that will give us 84. So we are dividing by 360. We are dividing by 360. So that would be, if you divide it by 360, you have 4675.1173. And that's approximately 44680. That's so 3 significant figures. Therefore, at CD is equal to 4680 kilometers. So we have succeeded in getting the distance between C and D. That's what we have done here. So that is that. We will now go over to trying to get distances along great circles, as we have finished that of a small circle. So okay, we continue by looking at distances along great circles. We have 2 questions on the board, and in order to continue, we have to draw the diagrams. So we locate the points 15 degrees north, 25 degrees east. So this is the first point. And then B, and this is our A. B, that's 3 degrees south, 25 degrees east. So that means it's the same longitude but different latitudes. This is 33 degrees south. So since it is a long longitude, our R is capital R. So we draw it outside. This is our theta. Then we have A, B. This is our A, this B. Okay. So we are looking for distance between A and B. So our AB is equal to theta over 360 times 2 pi capital R, because it's from the big center. Thickness is 0. So if you do that, that will give us theta. First of all, we need to find theta. So theta will be, since we have north and south, we have to add 15 degrees plus 33 degrees, 8, 4. And that is 48. So that will give us 48 degrees over 360 times 2 times 3.142 times 6,400. So we have to multiply out and then before we continue. So working it out with calculator or formula table, we have if you multiply out, you are going to have 1930 4.8 by dividing by 360. That will give us 5, 3, 6, 2.3467. Now approximately 1, 2, 3, 4. That should be approximately equal to 5,360 kilometers. So 3 significant figures. So that is the answer to question number 1. So we go over to question number 2 quickly to see how we can calculate at the same rate. So we have to wipe off and then represent it as 3. So now we draw again. That's question number 2. Now this north south. Then we go back 20 degrees south, 40 degrees west. So the distance is along 40 degrees west. Then 20 degrees south, 20 degrees south, that should be here, and 60. 20 degrees south, 60 degrees south. So that means we are talking of base and this. So that will give us C and D. So bringing it out, you can have something like this. C. So let's call this theta 1. Theta 1. So for us to find theta 1, we said that if we have south, we have to subtract. That means that will be 60 minus 20. And that is 14 degrees. So at CD will give us theta 1 over 360 times 2 pi capital R, which is the same thing as 14 over 360 times 2 times 3.142 times 6,400. So when you work it out, you will now have, after multiplying, we have 160,1608 704. We are dividing by 360. And that will give us 44. That will give us 4468.622, approximately equal to 4,470. That is 3 significant figures. So we have come to the end of question number 2, and then I'll show you how to solve distances along great circle as well as distances along small circle. So I'll solve one more question before we end the lesson. So let me quickly go to the next question before we round up. Now the last question we have on the board, it says an aeroplane flies from P, latitude 20 degrees north, longitude 10 degrees east, due east to Q, the same latitude but longitude 60 degrees east. If the journey takes 6.5 hours, we are to calculate the average speed of the aeroplane correct to 2 significant figures. So here again, we have to start by drawing the diagram and then fixing the points. So let's start. So we have this. This is our north and south. This is the center. So we are now going to locate the points. 20 degrees north, 10 degrees east. So let's use this to represent our 20 degrees north. Then 10 degrees east. So we can take this to be our P. And then again, we have another point, the same 20 degrees, but 60 degrees east. So that means we have this. And this is our Q. So we are talking of this and this. So let's take it to represent So for us to continue, we have to bring it out and have something like this. Then we have our key, we have our Q. Let's take this, let's represent it by theta. So how do we get the theta now? We are going to use our normal formula, which says that if we have east, we have to subtract. So here we have east, that means theta will be equal to 60 degrees minus 10 degrees. And that's 50 degrees. That's 50 degrees. So we are talking of arc EQ now. Okay. Arc EQ equal to theta over 360 times 2 pi r. And then if we continue, that will be we have 50 all over 360 times 2 pi theta r cos alpha. And remember that I said that alpha is always the latitude. So alpha will be equal to 20 degrees. Alpha is 20 degrees. So we move on. And that will be 50 over 360 times 2 times 3.142 multiplied by 6400 cos 20 degrees. And that will give us a check either with calculator or by working it out. You have 50 over 360 times 2 times 3.142 multiplied by 6400 times cos 20. Cos 20 will give us 0.9397. 0.9397. Okay. So we move on, and if we divide, we have this will give us, we can reduce it. Then this is 1, this is 18. So that will give us 5 times 3, 5 times 3.142 because we have divided times 6400 times 0.9397. 9397. So moving on, we have when you multiply, you have this will be over 18. So when you now continue, you will have this will give us 5. Okay, no, that will give us 94481 1968 all over 18. Yes. Okay. And that will finally give us 5, 4. Oh, that's 5, 2, sorry. 5, 2, 4, 8, 9, 5, 5, 3. To do significant figures 1, 2, 3. That should be approximately 6 to 2 or 3. It should be 1, 2, 3. 5, 2, 5, 0. 5, 2, 5, 0. I think this should be to 3 significant figures. So 3 significant figures. That is 1, 2, 3, 4. Okay. So this is now that is the distance covered. But we are asked to find the speed. And we know that speed is the same thing as distance over time. Distance over time. Total distance over total time. So we come up here again. So we come up, average speed is equal to distance all over time. And that is, we were told that the journey took 6 1/4 hours. That is 5,250. We are dividing by 6 1/4. Now you can use your calculator and check. And if you do that, we're going to have, this will lead us to 840 kilometers per hour. 840 kilometers per hour. So you have seen how you solved it. And we started by, first of all, calculating the distance from P to Q. And then, first of all, finding the angle between them, and then solving everything. Finally, we arrive at the expected answer. And then we now find the speed by dividing this by the time given. That is by dividing by 6 1/4. So I think that is so we have finally come to the end of this lesson. And please like, share, comment, and subscribe. If there's any question, you put it in the comment section. You can also check my other videos because I've posted a lot of videos, and all of them are useful according to the topic. So if there's any question, let me see it in the comment section so that I will find solution to the questions. Thank you and God bless you. See you in my next video.